Hey guys, so today we've got an LS430 2000 to 2003. This is a brand new harness built for a right-hand drive vehicle and using a manual gearbox. So let's do this. Right, so as discussed, it's an LS430 2000 to 2003. That makes it a 3UZ VVT-i that originally had a 5-speed auto behind it. In this case, it is a completely brand new harness to bring all the ECU and everything inside the vehicle. It's built for a right-hand drive car and using a manual gearbox. So as it is a completely brand new harness, first thing we're going to do is cut through to the photos of the whole build process of the entire harness. Once we've done that, we'll come back and we'll start going into the testing. So let's do that now and I'll see you in a second.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life. I never miss, that's fact, taking big swings, put your hand to the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean and I bring it to the mad light. Ain't got time to kill, I got time to feel, I took the red pill, I know life's short so I wanna live real, but how's it supposed to feel? How's it supposed to feel? How's it supposed to feel? They wanna say my name, but they holding back. They wanna say they hate, but they know it's cap. I ain't play no games, I just do that's fact. And I don't feel no shame, it's a mood you lack. I go crazy, nah, but I ain't lazy. Track after track, I work on this shit daily. Pass me the jack, right as fuel, got me hazy. About to unpack all these things I've been chasing. I've got visions in my head, like memories after death. To be a legend instead of something you can forget. I'm living up every breath, I'd rather lead than be led. I'll fill the seats as I spread with every word that I've said.
Right, so now you've seen that, and obviously you see exactly what goes into making one of these harnesses. Obviously we build them brand new in these cases, so we bring everything inside the vehicle, unlike the original ones where the ECU was designed to be here in a box. Okay, so what are we going to do today? First of all, we're going to go through the entire layout. I'm going to show you the entire harness, where everything plugs in, and go through all of the sub harnesses that are available on this particular harness. Then what we're going to do is we're going to pop into the testing, and that's going to be made up of two parts, one with just the ignition on and the other one with the engine actually running. So let's jump into the layout, and what we want to do is head right over to the ECU, and we'll start there and make our way around. So on the ECU side, it's really nice and simple. You've got 1, 2, 3 plugs there that make part of the main engine harness. We then have two what I call the body plugs. One section pops out and it goes into the fuse box over there. The other section pops out and it goes to your pedal, and everything is labeled. In this case, it's a nice long 2-meter pedal that's going up to one of our IS220, 250, 350 pedals over there. Right, also coming out of here is the section that comes out of the main engine harness and makes its way into the fuse box over there. Then we have the two customer plugs, so it's a 9-pin plug and a 6-pin plug, with this one having very sparse items on it. It's mainly for the OBD2 plug, which is over there, so you can read live data from the ECU itself. And what we'll do at the end, we're going to go through these 9 wires in here, but it's easier once I've gone through the whole harness. There's a couple of things that I'll refer back to when we get over to here. So that's that section over there. All the plugs in the fuse box are unique, so you actually can't plug the wrong one into the wrong place. All the plugs on the ECU are unique, so you cannot plug the wrong one into the wrong place. So that's nice and easy. Moving up along here, we then come to our grommet, and as you can see, we do have a piece of SCL heat shrink on there. That's epoxy lined heat shrink. Once the customer's got this in their vehicle and they're happy with the location of this, they can slide it up and down. Once they're happy, they can then heat shrink that down, and that'll obviously keep it waterproof so no water makes its way down inside the vehicle. Moving along from here, we're going to end up at our first breakout point, and this is a molded Raychem boot over here, T-piece, just to make it look nice. And obviously what we're going to do is we're going to go this way first, then we're going to come back and we're going to start going around there. So popping out of this section over here is going to be our first sub harness, and that's going to be ignition left. So that means that all of these coils are on a separate sub harness. So if you are doing servicing, you can actually just unplug here, pull out all the coils. Once you finish servicing, put them all back and plug in. So that avoids you having to undo these plugs continuously. And that's where these standard Toyota plugs, that's what tend to fail on lots of connects and disconnects, whereas these are much more capable of being connected and disconnected quite a lot. Right, behind that is the rest of the main harness, and that's flowing along into here, and it breaks out here towards the middle, and that goes to your first cam sensor of 3, and that is for the left bank inlet cam. Okay, moving along over there, it's going to pop down to about here where injector 1 is, and it's going to pop and break out over there and go to the oil control valve for the left bank. So that's this connector over here. Again, everything is labeled for you guys. These are labeled as OCV or oil control valve. This one is labeled as VVL. It's used for the VVT-i system. It's measuring the advance and retard of the inlet cams, because this is only VVT-i on the inlet cams on these engines. Right, same thing that breaks out over there and runs along with the harness for a small section, and that is your front cam sensor. So this is the one that's actually measuring the engine position. All right, these are measuring what the cam is doing in terms of the VVT-i. This is measuring the actual engine position itself. Moving along there, you'll see you've got two mounting points there and there that have little temporary clips in there to hold it in place, so that keeps it out of the way of everything. Obviously, I don't have an aircon, but you'd have like a belt running down here, so that keeps this all nice and out of the way. When you come down to here, it's going to split into 3 sections, and what we do is we split the oil up here at the top, so these harnesses work whether you have this oil filter housing that comes on an LS430, or whether you have like the one that works on a GS430. That one obviously comes out the back, so you need to split the oil pressure switch over here so you can bring it through here and down to the switch over there. So saying that, you've got the 2 breakouts that are going to go down to here now, and they would then come down, go through this little cavity over here, pop out the bottom over there, and the first one is your crank sensor, so that goes in directly over there, and then we've got our oil pressure switch which goes down there. So in this case, the customer does have an LS430, so this is exactly what his engine should look like. Whether he ends up changing the sump, obviously that will come down to the fitting process and what space he needs. The last section that breaks out over here, which is actually designed to go through here as well and come out over there, is then going to be your O2 sensor over there. So remember, on the original 3UZ harnesses, it came through there, which brought it very close to the exhaust. So we bring it down here so it stays well clear of the exhaust and of any heat. So it protects both the wire, the sensor, and the connector from heat fatigue. Right, so now that is that entire section over there. It is nice and neat and easy, and I said everything is labeled, so really straightforward to put on. Coming out of here, we then have 4 breakout sections, one being the main harness that's going to carry on around there, which we'll go to in a minute. But up at the top here, we then have our injector sub harness. So this actually controls not just the injectors, but also the vacuum solenoid valve for the acoustic control induction system. As you can see, it pops out over here and it goes to each of the injectors, and you have literally exactly the same thing on the other side there. Pops out and goes to each of the injectors. Right, so again, pretty similar setup. Number one, we can obviously make patch harnesses to go to aftermarket ECUs if you guys want. And in that case, then you have the ability to obviously swap injectors out. So that is one reason for it. The second reason, exactly the same with the coils. These connectors tend to fail because they keep getting plugged in, plugged out, plugged in, plugged out, plugged in, plugged out. With this, you can take off the entire inlet manifold by just unplugging this plug at the back, and all of the injectors and everything come with the manifold, so you don't have to disconnect every single thing if you want to remove it. So that's also a nice feature of making that, but obviously mainly for you guys, it's if you guys ever go off market EC and you want to change injectors, you can just phone us up. We can make you whatever injector connector you require. Next up, we have what I call the sub harness, and this is the one that goes underneath the intake. So I'll show you a couple of photos there. You'll see it goes to the starter solenoid and the 2 knock sensors. All right. Now, again, we do run twin core shielded cables to this particular connector, which is overkill for the standard sensors, but we do that so that you guys have the ability, if you do go with an aftermarket ECU, to actually use wideband knock sensors if that is what you want to do. Next up, out of the back here, we've got our ground, and there is only one ground for this particular harness, and it's bolting directly there with an M6 bolt, so really, really straightforward. Now, in this case, you can see the thick main starter cable. Obviously, we normally advise you guys just to reuse your existing one, or you can build a new one from there as well. But again, that just goes underneath there and goes and plugs or bolts into the starter motor. Really nice, simple, and straightforward. Right, let's pop over to the other side, and then we're going to go through over there. Okay. Right, so coming along here, we have our first breakout point at the back here. And that is then going to come out to our ignition right. So again, these are the sub harnesses. They go to all of the different coils over there. And normally what you can do is you can just use some cable ties to keep it attached to the main engine harness. Now exactly on the other side, the main engine harness is running underneath here. And it breaks out down there to go to the right bank inlet cam sensor, or VVR as we like to call it on the labels, as you can see over there. Right, moving along over there. Then the harness runs along there and it breaks out at the front here by injector 2. And then it's going to your coolant temp sensor, which is just over there. We add in a wire we call just temp, and it's designed to use a temperature sensor of your choosing, whatever's going to work with your gauges, if that is the way you are going and going to fit an aftermarket water temperature gauge. Now in this case, you can see down inside here, I've actually got a 3UZ non-VVT-i temperature sensor. There is a bolt usually in the 3UZs, and obviously that can be taken out and you can use a 1UZ sensor. So if your dash has the ability to adjust itself depending on what sensor you've got, that's a really nice, easy solution. No modification required, just undo the bolt in a 1UZ, one wire gauge temperature sensor. All right, also coming into there is your throttle plug. So again, as what we normally do is we provide the throttle plugs. Sorry about that. We provide the throttle on a sub harness. Now in this case, the customer's got a 5-speed engine. If he ever wanted to change the throttle out because he couldn't get his hands on another one of these, he can just phone us up and we can make him the sub harness that goes to the big 6-pin plug that goes over there. But basically it plugs into a 6-pin DTM plug there. It goes up to the 2-wire plug for the throttle motor, which is just there where my finger is. It comes over the top like that, down the other side, and then plugs into the TPS sensor that is over there. Okay, so that is the throttle. Let's go back over here. Right, next up we've got our oil control valve, so that plugs in here. So this is for the right bank over here. Again, labeled as OCV for oil control valve for you guys. Then we have our mass airflow sensor. So that pops in over there, and we give you plenty of length to do that, because I think this customer is also going with forced induction. We are actually remapping the ECU to be able to handle forced induction, but as stated, we know already that the MAF sensor and the injectors are going to be maxed out at 0.45 bar. So on the standard ECU, we can't really go any higher than that. For those obvious reasons. Most importantly with the MAF, because once that maxes out, it maxes out and it won't calculate any more air coming in and therefore won't add any more fuel. So even if you were to upgrade the injectors, it's not going to help because the ECU is no longer able to read the extra air that is coming in. Okay. Right, so then coming down over here, we then have the harness running down there till it breaks out down here at the bottom and goes off to our alternator sub harness. And again, we do this so that you guys are able to fit the later generation ones that have the 4-pin square plug rather than this 3-pin oval plug. Again, you can phone us up and we can make you these little sub harnesses, send them out the door, usually the same day. And you can then just unplug this one and plug in your new one for your alternator. Moving further along down there, and then you're going to see we go to our Lambda plug over here. So we've got the Lambda plug over here and the Lambda plug on the other side. And with the remap, these are the only 2 Lambda sensors that are required. They are actually controlling fueling, so you cannot do without them. They must be fitted to the engine harness itself. Okay, so that is the entire layout. As I said, everything is labeled for you, all the injector wires, all the coil wires as part of the sub harness. So it should be relatively straightforward when it comes to fitment on the actual engine itself. But again, it's really nice and straightforward. Just makes a U shape, goes around there, and then obviously pops out there to go to the ECU. Now, as I said, when we come to the end of the layout, we're going to focus on those plugs that the customers need to fit inside the vehicle. Now, if you watch any of my other videos, this is going to be a big repeat because this 9-pin plug is pretty much standard now across every single harness that we build. We did that so that it's nice and easy effectively. So on the 9-pin plug, starting from the top, we have our big thick red wire. Okay. Obviously, I've got my power plugged into there, but that is a 14 gauge wire, and that is required to have a permanent 12 volt supply, not an ignition 12 volt supply, a permanent 12 volt supply. Reason being is the ECU does have a permanent 12 volt supply to it. That is so that it can retain diagnostic codes, and obviously like long-term fuel trims, etc. So if you connect that red wire to an ignition source, every time you turn off the key, what's going to basically happen is the ECU is going to reset. Now, it's not a terrible thing, but at the end of the day, trying to diagnose an engine that keeps resetting itself every time you turn the key off is going to become an absolute nightmare. So I always advise, unless there's any reason you can't do it, always connect that red one to a permanent 12 volt supply. Next up is pin number 2, and that is going to be a black with a yellow tracer. Now, again, this is all written down in the paperwork, so you don't have to remember this, but I like to go through it so you guys can, when you're connecting up, you can just cut to this part, and obviously I'll go through everything with you. So number 2 is black with a yellow. That is a starter signal that requires a 12 volts. So either whether you're getting it from the back of a key barrel, they're pretty much standard giving out 12 volts, there's no problem. But if you are using like a push button start, do bear that in mind. Other side of the button, 12 volts. Other side goes to our black with a yellow wire. Next up is number 3, and that's a yellow with a green tracer. You can actually see it's connected to this little device over here, because I'm using it to make sure that that wire that I said, this little temp wire down in here, that is connected in the fuse box, and it's coming out on the yellow green wire, and everything is working as we expect it to. So when we come to start the engine, you're actually going to see some coolant temp displayed on the little dash there. Right, so that is that. Number 4 is going to be your gray wire. And this is a 16 gauge wire. This is for your fuel pump. All right. Now, the fuel pump is controlled via the ECU. What I will do is I will put a link up in the top there. I highly advise you guys watch it. I go into great detail on how the fuel systems work. It just, things like guys will ask, oh, I turned the ignition on and the fuel pump doesn't prime. That's normal. That's the way Toyota and Lexus do it. So don't be alarmed when that happens. But again, I give a full detailed explanation in the video, so I do advise you to go watch that. Next up is number 5, and that's a yellow with a red tracer. Now that is your check engine light. And again, you'll see I've got that hooked up to this cluster here so we can get a check engine light. We also fit an LED inside the fuse box. So if you guys don't connect these wires up like that, you can still see the check engine light is coming on so that you know the system and the ECU are turned on and active. Number 6 is a yellow wire, and that's going to be your tacho or tachometer or rev counter signal, whichever terminology you prefer. That is then coming from the ECU, and it is a 4-cylinder signal, so do bear that in mind. I know it's a V8 engine. It's a legacy item left over from the 3UZ non-VVT-i, where they use 2 igniters to run each bank, and so for the rev counter signal came from one of the 2 igniters, hence a 4-cylinder signal. That just seemed to stick and made its way all the way to 2010 with the last SC430 3UZ 6-speed. Okay. Next up is number 7, and that is a black with a red tracer. Now that is your ignition 12 volts. That's what's going to turn the system on. So remember that permanent 12 volt supply, that's not what your ignition is. That's just supplying power to all of the relays and everything like that. And obviously the permanent supplies required via the ECU, and also the one for the alternator as well that requires a permanent 12 volt supply. So the ignition one, the only thing to bear in mind is if you are using a key barrel, please check with your multimeter that you have an ignition source and not an accessory source. So on a key barrel, the accessory source will cut off when you move from the on to the start position. Okay. Now, as you can imagine, that's not ideal, because what's basically going to happen is as you go to crank the engine, you're effectively going to shut down the ECU. All right. So do make sure that when you find your ignition source, get your multimeter out, turn the key to the start position, and make sure that 12 volts stays and doesn't disappear. Disappears, accessory feed. Stays, ignition feed. Next up is number 8, and that is a pink with a blue tracer. Now that is going to be your alternator charge light. Okay. Again, I've got it linked into here, so it's going to help me display the battery charge light on there. So I'm making sure that that all works 100%. Now that is a negative signal that's given off by that one. So if you are using a older dash, what I do recommend that you guys do, and I have seen it in the past, is some older dashes, what they do is they'll backfeed through the cluster. If that is the case, the easiest fix you can do is change the bulb with an LED bulb. LED is a diode, therefore it only allows electricity to flow in one direction, therefore you cannot have any backfeed. If you don't have the ability to put an LED in and you do have a normal bulb and you are worried that it's an older cluster that will backfeed, then just fit a diode in the pink with the blue wire before you attach to your cluster. That way you will make sure that it doesn't cause the backfeed from the cluster, which I've noticed to actually keep the alternator alive and actually burn out regulators really, really quickly. And in one weird incident with the Volvo, it actually backfed all the way into the fuse box and kept the system alive. Next up is number 9, and it's the last wire, and that is a yellow with a black tracer, and that's just the one that's over there next to my pink with the blue. And again, that is the oil pressure light, so I've got it connected to there, so it will display the low oil pressure, the red low oil pressure light in the corner there as soon as we turn the ignition on. Okay, so that's connected to your oil pressure switch, which is down there. Right, so that is the 9-pin plug. That's pretty much standard across our whole range. So if you watch any of our videos, that's just a repeat of what you've heard before. Next up is the 6-pin plug. Now, as this has OBD2, obviously we need to fit an OBD2 plug so that you guys can get live data from the ECU itself. So you can see I've got my Toyota intelligent tester plugged into that, so I can obviously retrieve all the data from the ECU. The only other wire that's in there is a white with a blue tracer, and that is for the brake switch. Now, the ECU does require 2 signals in relation to the brake system. We've taken care of that inside the fuse box for you. So all we require you to do is to tap that into your brake pedal switch. Now, again, that is provided that your brake pedal switch does actually run the 12 volts through the brake pedal switch. If not, then connect it to the feed that goes to your brake lights. It is all fused in the box here, so you won't do any damage to the ECU. It'll pop here before it even reaches the ECU when it's giving the signals back to the ECU. So don't stress about putting it on the brake light switch. You're not going to cause a problem there. And like I said, if your brake light switch on your pedal is actually a ground operated system, then just use that wire and connect it to the actual 12 volt wire that goes to your brake lights. Okay. All right, so that is the 2 plugs that the customers are required to connect in their vehicle. So it's really, really nice, simple, straightforward. All of these harnesses obviously come with the welcome pack, not just the pinouts for the 9 and the 6-pin plug. We also have the whole fuse box diagram telling you exactly what each fuse does, what amperage rating it should be, and what each relay does, so you can help with diagnosis. Okay, now just on the diagnosis side, we do put the LED inside the fuse box, but unfortunately on the 3UZs you cannot read codes by bridging. You could actually bridge pin 5 and 13 on the plug there. We have put trouble codes in there. Now, the reason we did put trouble codes in there is actually so you can bridge those if you want, and you can read the timing with the timing light. So as I've done before in the past, you can put a clamp around cylinder 1. Hopefully your timing light will work just on the wires, but you can put it around there. Bridge those 2 terminals in the OBD2 port, pin 5 and 13, and then it'll lock the timing at 10 degrees so you can get your timing light out and check your timing without having to remove any of the covers. All right, but what you can't do is do the old-fashioned flashing of the check engine light to get the codes. Unfortunately, in the 3UZs, that is reserved purely for JDM models, not for European or US models. So you do require to have a OBD2 machine in order to get access to diagnostic codes and live data. Right, so I think that pretty much covers everything in terms of the layout. Again, super simple, straightforward. Everything is labeled. You should have no problem at all with putting this on. So what we're going to do now is we're going to pop off. I'm going to get everything ready, and then what we're going to do is move into the testing. Again, one with just the ignition on and the other one with the engine actually running. So let me get all the paperwork, get everything ready, and I'll see you guys in a second. Right guys, so now we're back again and we're going to be doing the testing of the harness, and as I said earlier in the video, it's going to be made up of 2 sections. One with just the ignition on and one with the engine actually running. So what are we going to be testing today? With the ignition on test, we're going to be looking at the check engine light. So I want to make sure the LED comes on in the fuse box. I want to make sure the check engine light comes on the dash. Then I want to check the charge light on the dash, and I want to check the oil pressure light on the dash. So all of those 3 lights should pop up there when I put the ignition on. Then we're going to move over to our OBD2 machine. So we want to make sure that it communicates, that it picks up that it's an LS430 ECU. When we're in there, we're going to then test the fuel pump relay. So I'm going to use the machine to get the ECU to activate the fuel pump relay. You should hear the fuel pump running and obviously hear the relay click on there. Once we've done that, then I'm going to go and I'm going to test the brake switch. So what we're going to basically be doing is providing that white with the blue wire with 12 volts. We're going to hear the relay click, and most importantly on the live data, we're going to see the stop light switch go from off to on, and then as soon as I let go back to off again. So that's all we're going to be doing in terms of the ignition on test. So really straightforward, nice and simple. Then we're going to move on to the engine running test. So first thing we're going to do is we're going to test the starter circuit. So we're going to supply the black with the yellow tracer wire with 12 volts. It's then going to turn the engine over and she's going to fire up. Once we've done that, then we're going to move over to the ACIS valve. So this little valve should do that after it starts up, and that's indicating that the ACIS valve is working. Now I do have a video explaining in great detail what the ACIS system is, what it does, how it works, and what it looks like underneath here. So I do recommend you guys go and watch that, full of useful information for you. Then we're going to move on and we're going to do the drive-by-wire test. So all I'm going to simply do is push the pedal. Engine should rev up. Super happy that it's all working. Then we're going to come back to the machine again and we're going to test both the oil control valves. So it's these ones over here. You've got one on each bank in the front here. And basically what the system will do is it'll advance and retard the cam. So the engine sounds like it goes really lumpy. And that just tells me that A, all the wiring is correct, and B, that the oil control valves are doing what they need to do. Once we've done that, then I'm going to go around and I'm going to unplug all the injectors one by one. Okay, that's going to test each and every single cylinder and make sure that it is firing correctly. Now, a heads up, these aren't actually plugged in all the way because it's easier for me to grab and lift up. So if I start the engine up and one cylinder starts misfiring, that's the reason why I just haven't plugged in any of the injectors, because it's much easier to pull them out one by one when I do that. So the test for it. Once I've done that and I've demonstrated that all 8 cylinders are firing exactly as they should, we'll pop back over and we'll go and look at the cluster again and make sure we've got a tacho or rev counter signal coming through there. And then lastly, we're going to look at the coolant temp. Sorry, not lastly, we're going to look at the coolant temp, make sure that that is coming through. And then we're going to move on to the diagnostics. So I'm going to go through some technical details, what you can, what you can't do. I did do a brief intro in the layout section for you guys, but we'll just go over that again. Okay, so let's jump into the testing with just the ignition on. So as I said, obviously red wire has 12 volts straight from the battery. And what we're going to do now is we're going to take the black with the red wire and we're going to give that 12 volts and that's going to turn the ignition on. So let me just do that quickly. So you can hear all the relays clicking, so that's fantastic. So the first thing I want to check is the check engine light, and we can see we've got an LED on there. We've also got our check engine light in the corner there, so that is fantastic. Moving over, we've got our charge light over there. So there's our little red battery light over there, and there's our red oil light over there. So once the engine starts up, obviously we'll make sure that those go out because that's what we're looking for as well. Right, so moving along, we're going to come over to our machine over here. And you can see I've already loaded up because it takes absolutely ages for this machine to load up. But I'm just going to go into System Select so you can see it is picking up as an LS430. Right, so that means the device is communicating via the OBD2 plug that we have installed to the ECU. So super happy with that. And as I said, the first thing that we're going to do now we've done that is we're going to do the fuel pump tests. Right, now you'll see here it says fuel pump relay and fuel pump. If you watch the video I linked earlier, you'll understand exactly what that means. We're also testing the fuel pump itself. And I'm going to flick that to on. You can hear the relay click and you can hear the pump going wild there. So I'll quickly turn that off. Right, so that's okay. So that means that the ECU is controlling the fuel pump correctly and when it should be. Right, so let's move on to the brake switch, and I'm just going to move down here to the stoplight switch so we can see the live data when it comes on. So you can see there we've got stoplight switch is now currently off. I'm going to take this and you can see the relay click over there, and you can see the stoplight switch is now showing is on. Let go of that wire from the 12 volts and you can see the stoplight switch is going off. So that means that is exactly what I wanted to happen. That is now then working exactly as I expected to. So as soon as you touch that white with the blue wire or supply the white with the blue wire with 12 volts, it then activates the relay, which then tells the ECU that the brakes are being pressed. Okay, so what I'm going to do now is quickly get the engine up to temperature. So obviously we're looking at things like the coolant gauge when we're doing part of the running test. So I'm going to do that now, be back in a second, and we'll jump into the engine running test. So see you now. Rightio, so we're back again, and now we're going to do the running part of the test. So I'm just going to do a quick recap. So first of all, starter circuit, just making sure that when I touch the black with the yellow wire with 12 volts, the engine turns over and starts. ACIS, we're going to make sure the valve just goes down like that. Drive-by-wire test, we're just going to press the throttle, and you can actually hear it's opening already. Then we're going to do the oil control valve test. That's going to require the OBD2 machine. Then we're going to test all the injectors and coils and make sure that they are firing as they should do. We'll come back and look at the tacho on there, and then we'll look at the coolant temp as well, and then we'll do the diagnostic. So first thing I need to do is get my ear defenders on. All right, so let's do this. So I'm taking my black with the yellow wire, going to supply it with 12 volts, and you'll see that the motor is going to start up. There you go, fantastic. So now we're going to move over here. And we can see that that has gone down. That's super what we're looking for. Drive our wire test. Fantastic. Now we're going to go into the oil control valves. We're going to go active test. Kill the power there. Rightio. Okay, so that is fantastic. Everything is exactly as I expected it to. So what we'll do now is we'll go through the diagnostic. So I did do a brief interlude in the layout section, but basically the ECU is remapped. So anything that's unnecessary, you can see we've got no automatic gearbox on here. We've got none of that set up there. So we've got absolutely zero error codes. So hopefully you would have seen, I'm just going to put the ignition back on again. You would have seen when we were running that the check engine light has gone off both on the fuse box and that. So if the check engine light does come on, that means there is a sensor that is required for the engine to run correctly, that there is a fault and it needs to be rectified. Okay, so what we're also going to do now is we're going to go and take a look at all the diagnostic codes. Well, 0 of them that should be on here. So you can see there we've got absolutely 0 codes whatsoever, and obviously I've started this quite a few times and I've had permanent power connected the whole time, so any codes that would have come would have been here by now. So we know we're happy with that. We've got absolutely no codes whatsoever, even though there's no automatic gearbox, no secondary Lambda sensors, none of that, all gone. Okay. Right, so what can you do and what can't you do? Number one, obviously you can plug in an OBD2 machine, you can read live data, you can do diagnostic codes, you can carry out active tests if you have TechStream or the Toyota Intelligent Tester. What you can't do is you can't do the old-fashioned way of just bridging pin 4 and 13 or 5 and 13 on the OBD2 plug in order to get the check engine light to flash the codes. Remember, I said that's for JDM models only in the 3UZ, US and European models that does not work. Bridging those terminals does not cause the check engine light to flash. As I said earlier, we do include the wire in there though, because of the functionality of being able to lock the timing at 10 degrees. So you can see that you've got your numbers across there. You've got 0, 5, 10 and 15 degrees. And on your crank, if I've been lucky enough, there you go. You can see you've got a mark in your crank there. I used a little white paint or Tipex or correction fluid, or whatever you want to call it. And obviously I've made all those numbers nice and bright, and also the mark there. Just makes it super easy when you're trying to look at it at a timing light. So if the engine's out before you put it in, might as well do that and make your life a lot easier. All right, so that's what you can do. Just bearing in mind that if you bridge those two terminals, you lock the timing at 10 degrees, no matter what RPM you're at. So basically what you do is if you leave that bridged, you're going to have no power because you're literally going to lock the timing at 10 degrees. So you're not going to have any use there at all. Right. I'm going to go through some things specific to this harness because obviously this customer is going to use forced induction. Now in this case, he is using a turbocharger as far as I remember. And like I said, we are remapping the ECU, or have remapped the ECU with the same one that we used on Speed Academy's LS430. If you want to go watch those videos of Speed Academy, it's the $6,000 sedan challenge, I think it is. The LS430 was supercharged, and so we're using that same map. Now then, when you guys are looking at doing something like this, whether it be with a turbocharger or with a supercharger, few things to bear in mind. Number one, as I said earlier, the mass airflow sensor and the injectors are going to hit maximum ability at 0.45 bar. You'll have to convert that to PSI, but I'd probably say it's about 6 or whatever PSI. Okay. Now then, it doesn't help changing the injectors because if the mass airflow sensor is maxed out, it's not going to read any more air and therefore it's not going to add any more fuel. You can't change anything about that, unfortunately. That's just the way it is. Okay. Now also, when you're doing a supercharger, it's relatively straightforward because you've got one intake pipe going to an air box and you've got your mass airflow sensor. Now then, if you're going to go with another system like a turbocharger, for instance, there's a few things to take into account. Okay. Those are, when you are running on a MAF-based system, the mass airflow sensor needs to calculate every single piece of air that is entering this inlet manifold. All right. Why is that important? Well, if you use a MAF, mass airflow sensor, and you connect it pre-turbo, as an example, right? If you then put a blow-off valve that blows to atmosphere, what you're doing is you're letting air out that the mass airflow sensor has already calculated. Okay, so if you connect the mass airflow sensor pre-turbo, you can't use a blow-off to atmosphere. You need to use a recirculating blow-off valve. Okay, so that'll basically recirculate the air back into the intake system rather than to atmosphere. So the engine will ingest all the air that the mass airflow sensor has calculated. That's super important because obviously the ECU is basing all its fueling calculations on how much air has come in. Remember, an engine is just a big air pump. That is all it is. And the ECU is just calculating how much air is coming in, and it's using the oxygen, the Lambda sensors to work out how much oxygen is left over in the air that's being mixed with fuel and burnt. Okay, so if you are desperate to run a blow-off valve to atmosphere because you like the noise or whatever tickles your fancy, then what you ideally are going to have to do is you're going to have to use the MAF between the turbo or intercooler and the throttle body itself. Okay. So again, if you had to put the mass airflow sensor close to the throttle body, have the turbo there feeding into an intercooler, then popping out like there, then there's a few things you've got to take into consideration. Number one, there are rubber O-rings on these. I don't know if you can see it there. There is a rubber O-ring in there and it does bolt down. But you need to bear in mind that obviously you are putting positive pressure. Okay, that means there's going to be a force acting against that is going to obviously try and push it out. So do bear that in mind when you are doing that. And then you can blow off to atmosphere either at the turbo end, so like pre-intercooler or whatever you want to do, and that's not going to affect anything because the engine is still calculating how much air is physically entering the engine itself. Okay. If you do put this sort of, how can I say, a pre-turbo as well, what you might want to do for you guys is to fit some kind of intake air temperature so that you can monitor between the intercooler and the inlet manifold. Just in case, obviously, the air that's coming in to the engine itself is much hotter than the air that is entering and the mass airflow sensor is measuring. So you can see that live data over there. So if you see on the live data that the air temperature is, for example, 55 degrees centigrade, okay? And you put your own intake air temperature sensor just before the throttle body and it's reading 85 degrees, then clearly it's not going to be the most ideal solution because the ECU is going to use its information and tables, and it's going to take that reading of what temperature the air is, and in actual fact, what's coming into your inlet manifold is about 30 degrees hotter. Okay, so these are all things just to take into account when you guys are fitting turbochargers to systems that use a mass airflow sensor. All right, so hopefully that's been super helpful, especially for Daniel. But yeah, we're all done here. So we are going to get this all boxed up, sent over to him all the way in South Africa, actually, where I'm from. So yeah, let's get this all boxed up so Daniel can get his car working. And obviously it's close to Christmas, so hopefully we can get this to him with a courier before Christmas, so we can have a Christmas with his engine in the car running. But if any of you guys have any questions, technical queries, you can find us on Facebook and you can send us a message there. We try and get back to everyone as soon as we possibly can. You can also comment down below. Again, I don't know what you guys don't know, so if you guys have any questions, please do ask. We can do videos on it, explain certain things of exactly what it is. Obviously, we're focusing mainly on the wiring, more so than, you know, actually working on these particular cars, I'm afraid. But yeah, if you have any technical questions, anything you'd like to know, please feel free to comment down below, or ask us on our Facebook. And again, if you guys like these videos, you can like, subscribe. If you didn't like it, then, you know, tick the box that you didn't like it, but let me know exactly what you didn't like, and then I can hopefully improve the videos for you guys. But yeah, thanks for watching, guys, and we will see you again soon. Next up is going to be a 1JZ GTE VVT-i into an IS200. So if you guys want to see that, stick around and we'll do that in a minute. Bye-bye.